Hello everyone, hope you are doing well. Once again I am before you with another video, and in this video I am going to solve problem of the day from leetcode. So let's get started. The problem is saying that given two strings word1 and word2, return the minimum number of operations required to convert word1 to word2. So here we'll be given word1 as a string and word2 as another string, and we have to convert this word1 string into word2 string, and we can perform these operations. Insert a character at any place, we can delete a character from any place, and we can replace a character with any other character at any place. Let's take this example 1. This example contains word1 as this string HORSE and word2 as a string ROS. Now let's try to apply the given operations randomly and find out in random order, if I perform the operations, how many operations will I need to convert word1 into word2. So in operation 1, if I replace this with R, this with this R, so first character of both the strings will become same. So I'm going to do this RORSE. My string word1 will become RORSE. In second operation, the second character of both the strings are same, so I'm not going to perform any operation here. And in third character it is R here, it is S here. I'm going to replace this R with S, so this part will become ROS. In second operation I'm going to replace this R, it will become ROS SE. Now I have ROS as a part of my string in word1, and there are two extra character SE which I will remove, as each character operation on each character takes one operation. For removing these two characters it will cost two operation. In one operation I will remove S, my string will become ROSE in third operation, and in fourth operation I'm going to delete this character E. In fourth operation my string will become ROS after deleting this E. So it took me four operations for converting this HORSE to ROS. Are there any other ways which with which we can convert this HORSE to ROS with lesser number of operations? Let's find out. As I am here getting 4, and in question the output is 3. So let's try another way. What if instead of replacing it with S, I delete it? So I will get this S here as required as third character. So in another way, I am going to delete this in next operation. In second operation I'm going to delete. Let me write in order. After performing one operation it will become RORSE. Here I am using the same previous operation, I am replacing this H with R. Now in second operation I am going to delete this R, my string will become ROSE. In third operation now I have got ROS in my string as a part of this string word1. Now I am going to delete the last character which is extra here. In third operation my string will become ROS, which is the, now I got three operations, which is the required number of operations. So there are many ways by which we can perform operations, but we have to find the way which takes minimum number of operations. Now let us see the approach for solving it. What I'm going to do, I'm going to initialize two pointer I and j, which are pointing to the first character of word1 and word2. If they happens to be same, I will not do anything. I will simply increase my I to next index and j to next index, because I am not going to spend here any operation. If they are not same, then I will try with each of the three operation given. I will try with insert, I will try with delete, and I will try with replace. I will try both these operations, and the operation which gives me minimum number of operation, that I will consider. If I perform insert here, I'm going to, if I am inserting here a character, I will simply insert which is required. Here R is required, so at first place I'm going to insert R, then my string will become RHORSE. Here I will not move my I will remain here. I will move my J to the next character because I know I have inserted the same character at the required place, so it is not required to check. I will increase my J here, so I will remain as it is. I will remain as it is. J will increase. If I delete, if I delete this character from my string word1, what will happen? It will become ORSE. Here in this case, for delete, I will move to the next character, as I have deleted this character, current character. Now I'm going to check whether this character is same as the corresponding character in string word2 or not. So J will not move, I will move to the next character. Here I will move by 1, J will remain as it is. This is for insert operation. For delete operation, now let's see replace operation. If I perform replace operation here, I'm going to replace the first character with the required character, which is R here. It will become RORSE, and index I, which was previously pointing at H, will move to the next character, and J will also move to next character. As we know that now both the character first characters of both the strings are same, so no need to check them again. So I will move my I and J to next position. I will become I plus 1 and J will become J plus 1. This is the main part of the code. Now let us see the code to get its better understanding. As the function which is going to solve this problem is going to be a recursive function, hence I am using here dynamic programming. Otherwise it is going to show time limit exceed. And for dynamic programming I am using memoization, and for memoization I am using this vector of vector in 2D vector. In this 2D vector, number of rows will be number of characters in this string word1, and number of columns will be number of characters in this string word2. Initially I am going to fill all the cells with value -1, indicating that for particular value of I and j sub problem, the answer is not yet been calculated. Now I am calling my function solve with string word1 and word2 and these two zeros. These two zeros are the initial values of I and j, which are initially pointing to the first character of string word1 and word2. And now I am passing my 2D vector dp here. Here I am receiving are the parameters, and this is the base case of this recursive function. Here I have written in base case, if I becomes equal to word length, I am going to return word2 dot length minus j. Now why I am doing this? Let us find out. Suppose suppose a example. Let's say word1 is Ross and word2 is horse, and I have to convert this into this. Initially my I is pointing at first character, j is pointing first character here, and after traversing through this string, this will become HOR in this place, and I will come here. and j will come here at as uh, after r after 3 characters. Now I have to add these two characters here for making it horse. So number of operation that is going to take is 2 here. So I at base case I have to return 2 at this condition. Now from where this 2 will come? This 2 will come by doing this word2 dot length minus j. In this case word2 is this and its length is 5 and j is at 0 1 2 3 index. It will give me 2. So I have written this word2 dot length minus j here in the base case. Similarly, for a case in which the word1 is larger than word2, my j will become word2 to length before I will become equals to word1 dot length, and here I have to return this word1 dot length minus I to delete two extra characters. Here I have to add two extra characters as they are required. In that case, in which word1 is larger than word2, in that case I have to delete two characters. The number of characters there are extra in this string word1. So I will similarly calculate the value of these extra character by doing this word1 dot length minus I. Now hope you have understood the base case. Now after base case I am checking this for particular value of I and j if the answer exists in my dp2d vector or not. If it exists, then I will, without making any calculation, I will simply return it dp I and j in else part. If it does not exist, then its value will be -1 as I have placed here -1. And now I will check if I and j, the word characters at index I and j are equal or not. If they are equal, then I will not do anything. I will just increase my I and j, and I'm going to pass the rest of the string to check for recursion. And here my number of operation will not increase. If these characters are not equal, then I will come in else part, and then I will try all these three operations separately. As I have performed one operation, I am adding here 1 as it cost 1 for inserting one character, deleting one character, or replacing one character. So I am adding 1 in each part here. And after performing operation, I am giving rest of the string for recursion to solve. And why I am doing here j plus 1, I plus 1, I plus 1 and j plus 1, I have discussed it earlier. And which one comes to be the minimum, that I will consider as my answer, and I will store it in my 2D vector dp, and then I'm going to return it. In this way this problem is solved. Hope you understood the problem, and now I'm going to see you in next video. Till then, bye bye. Thank you.